Hi everyone. In this video, we are going to discuss this example. Okay, we are going to study how to check the given differential equation is exact or not, and if it is exact, how to solve. Okay, this thing also we are going to discuss with the help of this example. Okay, so if you have the differential equation in this format, m dx plus n dy is equal to 0. Okay, the differential equation should be in this format where m and n both are functions of x and y, right? If dabba m by dabba y, that means partial derivative of m with respect to y, is same as partial derivative of n with respect to x, then we say the given differential equation is exact. If you see this given example, basically it is not in its standard form. Actually, the all function should be in left hand side, and in right hand side we should have just 0 only. But we are having something different. So I will try to bring that format first. Okay. So let me write. We have. So to bring 0 in right hand side, the entire term I will shift to the left hand side. Okay, so let us see what will happen. Y sin xy plus xy square cos xy dx. Okay, so we have a minus sign over there. If you shift it here, it will be plus. So plus x sin xy plus x square y cos xy dy. Okay, so in right hand side we have 0 only. So now the given differential equation looks like this. Okay, multiple of dx is our m, that means this is our m, and multiple of dy is our n, that means this is our n. Okay, so let me mention what is my m and n. So here our m is y sin xy plus xy square cos xy. What is my n? This is my n, x sin xy. Okay, simply I need to note down x square y cos xy, right? So now see, I got my m and n. So now we have to check whether these two partial derivatives are equal or not. If they are equal, then only we can say it is exact differential equation. So let us find dabba m by dabba y. So now dabba m by dabba y, partial derivative of m with respect to y. So I'm going to differentiate it with respect to y. I'm going to find this derivative. But see, addition is there, two terms are there. There is addition, so I can take separate derivatives. So derivative of y sin xy plus derivative of xy square cos xy. So I always take constants outside. If there are any constants, I always take outside. See, here we have two terms. First is y and sin xy. In both terms we have y. That means there is no any constant. So if there is a product, I have to use this formula to find derivative. That is derivative of u into v. So u derivative of v plus v derivative of u. This formula I supposed to use to find derivative. So what is my u? So y is my u, and what is my v? That sin xy is my v. So with the help of that formula, first into derivative of second plus second into derivative of first. So y as it is, I will take the derivative of this sin xy plus sin xy as it is, I will take the derivative of y, u into v, first into derivative of second plus second into derivative of first. Let us move further. So, but in second case, okay, so x is constant, you can take it outside. Since when you take partial derivative with respect to y, x is constant, I can take x outside. So derivative of y square cos xy. Okay. So in next step I will find this derivative. Let us talk about this y sine. Okay, what is derivative of sine? Derivative of sine x is cos x. Okay, so if you don't know, I will mention here derivative of sine x is cos x. So its derivative will be cos xy. But see, inside sine we have a function xy, so I supposed to take its derivative again. That is called chain rule. Whatever inside the function, we supposed to take its derivative again. Okay. Plus, let us move further. Sine xy. Derivative of y with respect to y is always 1. Okay. Let us move further. Plus x. But see here y square cos xy. So y square is a variable or function. Cos is also function. It means again I need to use this formula u into v. This y square is my u and this cos is my v, right? So u into v, first into derivative of second plus second into derivative of first. Y square as it is. So derivative of what? This cos xy. Cos xy plus, okay, so I want some more space to write. Let me remove this part. Okay. Okay. So cos xy as it is, derivative of y square. Okay, let's move further. So this is equal to y cos xy. So here x is constant, it will come outside. So x will come outside, simply we have derivative of y plus 1 into this sin xy, you will have sin xy plus x y square. Now we have to find derivative of cos. What is derivative of cos? Derivative of cos is minus sign. Derivative of cos x is minus sine x. This formula I am using here. Tell me what will I get? Minus I am writing here. So sine xy, again derivative of xy. So if you have inside the bracket anything, again we should take its derivative. So I am taking derivative of xy. Chain rule. Cos xy, derivative of y square. So here I use this formula. Derivative of x raised to n. Derivative of x raised to n is n x raised to n minus 1. Whatever the power we have, we write it first, we reduce the power by 1. So here the power is 2. 2 will write here, we reduce it by 1, so 2y square. Okay. So this is equal to y cos xy into x. Derivative of y with respect to y 1 plus sin xy plus x minus y square sin xy, I am writing as it is, into, so x is constant, it will come outside. Derivative of y is 1. Getting the point? X is constant, I took it outside. Derivative of y 1 and this 2y cos xy. So it is almost over. This partial derivative is almost over. Let me write it properly, simply. So this x into y, so xy cos xy, this plus sin xy, right? I will take the product here. So minus plus minus minus x into this x square and this y square, x square y square sin xy plus this x into this 2y. So 2xy cos xy. So I hope it is visible here if I write. So let me write what we have, this sin xy, sin xy, okay, xy cos xy plus 2xy cos xy. See, both terms are same, just it appears one time, it appears two times. 1 plus 2, total 3 xy cos xy and this minus x square y square sin xy. So finally we got the derivative. It was very lengthy problem actually, partial derivative. So we got the derivative of m with respect to y. I got its derivative. So now still second task is remaining, that is derivative of n with respect to x, and both derivatives must be same, then only we say it is exact differential equation. Okay, so see, now what will I do? Actually I have told you what will be the derivatives, so that's why I will try to skip few simple steps. Okay, so we can do it fast. Now let us find derivative of n with respect to x. As you can see here, there are two terms, right? So I will take separate derivatives since addition is there. So derivative of x sin xy plus derivative of this x square y cos xy. Okay, so I took the separate derivatives. So now you can see there is a product of two functions. You can see here x is my u, sine is my v. Again u into v formula. Several times we are using the same formula here. Okay, so what will be its derivative? Try to say x derivative of this sine xy, right, plus sine xy as it is, derivative of x. Let us move further, plus here y is a constant, so it's better to take or better to keep constant outside, so we can easily find the derivative. So I'm keeping y outside, so u into v, x square is u and cos xy is v, so x square derivative of cos xy plus cos xy derivative of x square, right? So I'm using u into v formula several times, and if there is any complicated function inside any function, we supposed to use chain rule again. Okay, so let us find derivative. So x derivative of sine is cos xy, but see whatever inside it, we supposed to take its derivative again. Okay, I'm taking its derivative again, so let me show you. So derivative of xy again, but see what will happen, this y is a constant, it will come outside, and derivative of x only. What is derivative of x? 1. So y into 1, we have y. So let me write y directly, y plus sine xy, derivative of x with respect to x, 1, 1, 1. Okay, so yes, this step is over now. Let us move further, plus y x square. What is derivative of cos? Derivative of cos is minus sine, so minus I'm writing here sine xy, but see again derivative of xy, so again derivative of xy is same, y plus cos xy, derivative of x square is 2x. When you have x raised to n, derivative will be n x raised to n minus 1. Okay, so there is very less space to write the solve the problem, but no worry. Okay, I will do it here, I will manage. So this is xy cos xy, xy cos xy plus sin xy. I will take the product here, minus, okay, plus minus minus x square, y into y, y square, this sin xy plus this 2x into this y, I am solving the bracket, 2xy cos xy. So finally what will you get? Sin xy. Okay, this xy cos xy, 2xy cos xy, terms are same, it appears one time, it appears two times, 1 plus 2 total 3 xy cos xy, and this minus x square y square sin xy. So let us check both are same or not. Okay, x sin xy, yes, 3xy cos xy, second term is also same, minus x square y square sin xy, yes. Okay, though both partial derivatives are same, so we can declare it is exact differential equation. So there is no more space to write, just make a screenshot of it, then we will move further. So see, purposely I have kept m and n as it is, okay, since we are going to use. So okay, to make it different, to show it different, let me draw one line here. Okay. So here we have got, so therefore delta m by delta y is equal to delta n by delta x. So both partial derivatives are same, so you can see exact differential equation. The given differential equation is exact. So now the question is, if you have exact differential equation, how to solve? So there is very simple method. Actually it is addition of two integrals. Solution is addition of two integrals. M treating y constant dx. So we have to integrate m with respect to x by treating y constant, and the second is terms in n free from x dy is equal to c. That means if there are any terms in n which are free from x, there should not be any x, then we have to integrate it with respect to y. We need to add these two integrals and is equal to C. That will be the answer. Okay. So yes, let us do one by one. I will focus on first integral. Consider integration M treating y constant dx. Okay, what is my M? This is my M. You can see addition is there. When we have addition, we take separate integration. So let me directly write integration y sin xy dx plus xy square cos xy dx. So when we have any constant, we always take outside. Y is constant, we have already mentioned. So y will come outside. Okay, integration of what? Integration of just sin xy. Here y square is constant, will come outside x cos xy dx, right? Okay, so now integration of sine, but see there is no simply sine. Inside the sine we have xy, so maybe you will get confused how to find the integration. Getting? No need to worry. So we know the formula, integration of sine x is minus cos x. But see, if you have integration of sine ax, it is minus cos ax upon a. If you have any constant multiple of x, okay, we keep the same formula. Just that constant we write in denominator. So similarly, y is also constant here. Okay, y is constant. So at a place of a we have y. So what will be its integration? Tell me. So its integration will be, yes, try to say, it's minus cos xy. Okay, we write the same, and the constant term we write in denominator y plus y square. Now we have to solve this integration, but see, it is not that much simple. The reason is cos xy. So if we have variable here, x is also variable, product of two functions. So in case of integration, we have a product of two functions. What we do, let me show you. We use this integration uv formula. What is uv formula? It's quite simple. uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus and so on. Okay, series we get. You can easily see we have alternating minus plus signs, right? You can easily see some dash over here. It denotes derivatives. U is as it is, first derivative, second derivative, third derivative, and in suffix of v we have some numbers. It indicates integrations. First integration, second integration, third integration, fourth integration. It means we have to take derivatives of u and we have to take integrations of v, right? So if you have product of two functions, the same case is here. We have some u and we have some v. But see, there is a rule of choosing our u and v. Okay, so that rule is, if you have any vanishing terms, that means generally when we have polynomial term, okay, we consider the first and the remaining function we consider second. Okay, actually the LIT rule, LIATE rule, but see, I will not go in details since in this example that is enough. Okay, x, that will be my u, and cos xy is my v. So let us apply that formula. You can see u as it is, x as it is, right? v1, integration of cos, the integration of cos is sine. Integration of cos is sine. But see, y is a constant and we always write constant in denominator. I have already told you here, right? Integration of cos is sine, y is constant. So if you have any constant multiple, we write in denominator. Let us move further. After that, we have this minus sign. U dash, derivative of u, derivative of x, which is 1. v2, one more integration of this v1. Okay, it's integration. Integration of sine is minus xy. And see, one more y will come out in denominator. One y is already there because of integration. One more y will come in denominator. So y into y square plus u double dash, one more derivative of this 1. But see, derivative of 1 is 0 and all remaining derivatives will be obviously 0. It means this process will terminate here. Okay, and we get this answer, right? Let us move further. Okay, so let me remove this part which is not required now. Okay. Okay, that's it. So now simply we have to simplify this one. Y will get cancel, minus cos xy, minus cos xy, right? Let us see what will happen. Looking complicated, but see, I will write. I will solve it step by step. X sin xy upon x sin xy upon y, minus minus plus cos xy upon y square. That's it. So this is equal to minus cos xy plus. Now what will I do? I will multiply each term by this y square. If you take the product of this first term and y square, one y is in denominator, y square at numerator, one y will get cancelled and you will have xy sin xy. So now I will take the product of this second term and y square. So you can easily see that cos xy already has y square in denominator. If you multiply by y square, this y square will get cancelled. And we have cos xy. See, minus cos xy plus cos xy will get cancelled to each other. And you will have here xy sin xy. Yes, finally we got it, right? So we solved this integration and simply we got this simple answer. Let us go for the second integration now. What is the second integration? Integration terms in n free from x dy. Terms in n. Where is my n? Where is my n? This is my n. So actually how many terms are there? Two terms are there. In n we have two terms, first term, second term. There is a x, so you cannot take the first term. What we want? Free from x. There should not be any x. In first term we have x, we cannot take. In second term also we have x, we cannot take. That means we cannot take any term of n. So that's why value of integration is 0. Now the solution is, so let me write here, therefore solution is, okay, I will continue with the same. Solution is, this is a solution. This is solution. Okay, we got its value. Its value is xy sin xy. Let me put xy sin xy plus this value of integration is 0. No need to write, is equal to c. So this is required answer. Okay, so this is required answer of given exact differential equation. So in this way we solve this example. Make a screenshot of it and then we will stop. Thank you. See you in next video.